All right, I believe this is for Class 7 and ME370 by request. One of the students asked that I do a little demo that I did in class for using SolidWorks FEA on this problem. Whatever edition I got this out of, it was 3/122. We got this eye hook. It's got a 6 millimeter diameter wire. It's bent, so its inside radius here is 10 millimeters. Also, this curvature is 10 millimeters. And we have 300 newtons, and we want to find the stresses at AA. We also might want to find the stresses at BB, which appears to me to be a line that looks like it's about 45 degrees, I think. Well, we'll try to see. I'm not sure I'll be able to get that one. But anyway, here is the problem 123 where it asks those two things. So I'm going to attempt to get the same results as I got by hand. I didn't think that... Do I have those results handy? Let me see. Let me see if I have those results handy. I'll pause for a second. All right, in a previous video, you can see how I got the inside stress at A was 233 megapascals, and the outside stress was 145 megapascals. This in tension on the inside, compression on the outside. If you were going to look at the other one where I got put this through here, and I think I decided, oh, that looks, it was 30 degrees. I decided that's how, yeah, okay, it's from the geometry of that. So I'm going to try to use that for the plane in which I try to find this thing. I found that I got 116 in tension in the inside and 72.7 in the outside. So let's try to see if we can replicate those values, right? So we'll come back to these later. Okay, so here's where I've made it already before. So I'm gonna demonstrate it though. So let's start out with a new part, and we'll build it. And some things I always do, I always make the background white. Make sure I get the units straight in the beginning. I'm gonna pick the right plane first because that's where I'm going to make the wire profile, or the wire diameter face, I should say. And I made a circle on the origin, and I made it 6 millimeters, I believe is correct. So now I'm going to flip over to that direction right there, and on this front face, I'm going to my plan is to sweep this around and to make the body, to make the thing, right? So I'm going to start by using a construction line, and I'm going to plot out a diameter here, which is going to be so I have to kind of plan it out just a little bit. Let me put this out here. I'm going to try to do this diameter right here. So if you notice, this is 10 millimeters, and so that's 6 millimeters, so there's 13 millimeters to the center there, from here to the center line of this, and I want the diameter, so it's going to be 26, I believe, right? So we'll make this thing 26 millimeters, and this distance is not going to matter so much, but I want to reduce it some. I think I made it 30 in class. I think that'll be fine. Okay, now I need to cut this at some point, so I'm going to push it right up to there, and it doesn't really matter where I cut it. If you take a look at the original right there, it's this one. That's where I'm cutting it. So let's see, bring this back up. But maybe I could give it a dimension. Maybe I'll make it like 30 degrees. No, I'll make it like 45 degrees. There you go, 45, something like that. So I can cut in between the two lines I already have. It's because I have a line there and there. So there, I cut that apart. Now I want to extend this over to here. So that's a regular line. I would run that. And now I want a radius right in here. Now I think I might have made it wrong before. All right, so let me go back and take a look at this. This is a radius to this. So this would be 10 millimeters, but it needs to be 13 millimeters, okay? Because I need this radius right in there. So what I did in class, I think, might have been a little off. So let me put the type 13 in there, and that should go right there. Let's see if it'll. Oh, there it goes. Yep. All right. Oh, it didn't accept it. Oh, I didn't accept it. Oh, I think I had a accidentally hit. I don't know. There you go. Did it? It worked that time. All right. So there's my 13 right to there. All right. I think I got it. In terms of the modeling of the thing. And now I can just get out of this sketch and go to features, and it will sweep these two, and that we'll grab a hold of that. Oh, it already had that sketch, so you can see that it worked out pretty well. And that looks close to what we were trying to do there, right? All right. Now, before I go to the FEA, I want to add some split lines in here. So the first is just going to be a split line. Let's see, we're going to add a curve onto here. So I will take a splitting thing, and you can hover over this, and you can see this is the splitting body faces, and I have intersection selected. So here I'm going to use this top plane, and I'm going to slice that part right there, and you can see it is yellow. That's where I'm going to put the forces on, so that's why I'm putting that thing on there. I also want to have a reference plane that's parallel to this one, but I'm going to flip it over to the other side. I'm going to flip the side. Yep, I landed right in the right spot. All right, I would have adjusted this to get there, but that's the spot I want, because I want to be able to do an analysis right out of there. So I'm going to keep that. Now I'm going to have to do a little bit of monkey business. I'm going to add a axis that's in between that plane I just made and that plane. And that should be enough. Now what I want to do is I want to create a new plane, and I'm going to take my top plane and this axis, and I can, if I do this correctly, take an angle and rotate this. And so now it's going to be 30 degrees, I believe, like right there, right? And if you take a look at this, you can always just stretch any plane around. That looks correct, right? That looks like that axis right there. It passes. It looks like it passes right through that point. I don't know. Yeah, I think that's going to be correct. It looks like it kind of passes, not quite passes through that point. I believe that you want to go through there. So that looks right to me. I might be a little off. I think that's correct. So anyway, I'm going to insert a split plane. So insert a curve, split line. We'll take that and go right to there. Boom. Yep, so it inserted, it broke it in, okay. Oh, it might already have been in there. Let me see something, one second. Yeah, there might have already been, actually it might have already been there, to tell you the truth. I might not have needed to do anything with that plane. I gotta wonder, let me see, let me go back up through here. Yeah, I think that plane was already there, yeah. Just the nature of the way these things were made, we would have had that cut line, so. I'm going to hide that. All right, so now we go to the FEA. You have to make sure you turn this on, by the way. If you don't have it on already, you go to add-ins right here, up by that little gear at the top, and put in SolidWorks simulation, and then you can also click it over here under Start so that it'll show up every time. And let's see. Okay, so when it'll show up right here. Here's simulation, and you can click a new study. There's a couple of things. Simulation. Don't go simulated advisor. Just go to this. I'm your advisor. All right, we're choose static from all these different choices. And so now we have a study. It'll appear down here at the bottom. It's the first study. And we want to go down the list. Usually, we go to this first item, right click it, hit edit, apply, edit material. And this pops up. We'll just choose steel. It won't really affect hardly at all the stress analysis. It will affect displacement, but for the most part, you can pick any steel here and you'll get the same results. All I really care about is the elastic modulus. You can see it's about 29 million. And the units don't matter here. I mean, even though we're in metric, it'll figure it out. So I'm gonna hit apply. This doesn't disappear, it just stays in there, so you hit close. But you can even see that it changed color just a little bit. I guess that's what they decided steel looks like. You don't need connections because those are for multiple parts. Then you put some stuff in between them, and we only have one part. Fixtures, that's the boundary conditions. There's a bunch of different ones you can choose from, but fixed geometry is easy. Just go to there and click right here. And now we've got that completely fixed as if it was in a hole or welded or whatever, whether it was in, screwed into a thing or something like that. So we hit OK, and now we put our external loads, right click it. Bunch of different choices again. We're going to put force onto this, and the preview jumped and had a little quirky thing that's putting those errors there. This is where we want to put our section, but we want to be able to put it into the plane that's going downwards. So we need to do the select direction one. Now this one you need to select some kind of thing to be your reference. I usually find it's good to use like maybe a plane. And once you have that plane, now you can kind of like start to decide, there's a number of ways that you could approach this, but most of the time I just use the previews, and I can hover over this and try that direction. And sure enough, that is the direction I want, except I need to go reverse. So I'm going to hit reverse direction. You can see the arrows, barely you can see the arrows that are right in there. And then we had 300 newtons. And hit OK. And now we're set up to go. Our next thing, as we're going down this list, is the mesh. Right click it. I can just create a mesh and not even try to change anything. I can show you what that looks like. Boom. And it's using all tetrahedrons. In here you can kind of see that they're three, am I saying that right? Yeah, I think so. Tetrahedrons, they're all triangles, like little pyramids. Somehow I'm questioning myself with the terminology, but that's okay. We can go ahead and hit run right now. And it might be good enough. We could refine this. Let me go to the mesh, and I can show you the mesh code right here. And you can just go here to fine. And you can see that it made a tighter mesh. But let's go back to the coarse mesh and see if there's this is always a good idea to like do a little bit of an investigation into what the cause and effect of the mesh, and see if there's, but not to go too crazy and waste a lot of computer space or and time solving something with a really fine mesh. Try it out at first to make sure it gets solved. So anyway, we're going to hit the run. And there, that's that quickly. It solved it. By default, it always goes to von Mises stress, which we will learn about soon. It's a very useful generalized stress, especially for FEA. It works really well. We'll explain what it is in a bit. I want to, before I go and investigate the stresses, let me do a little bit of changing of the display. So I'm going to edit the definition. And instead of von Mises stress, I'm going to take stress. I'm a little nervous about taking stress in the X direction, because then it's not going to work so well when we go to that section BB. It'll work really well in section AA, but not BB. Let's leave it as von Mises stress. I'm going to change this to newtons per millimeter squared, which turns out to be a megapascal. And I don't really care about the deformation. There's a visual deformation that they put on there. You could see that you could physically see that that the thing is bent. We'll animate it so we could see that. But that doesn't really matter to us all that much. The next tab up here is well, I can show the maximum and the minimum onto their annotation. The minimum doesn't make any sense when being in von Mises because it should be 0 somewhere probably. Here's something I really don't like is when people use the default values and we have these weird values in between things. So we can see that it's somewhere right around 230. I'm going to go ahead and make this easy, but quite often I would suggest that you attempt to make it put a little more investigation into it. So I'm going to make this 0 right now. Maybe I'll fix it here in a second. I'll put some more thought into it. I don't like doing the scientific notation. I would rather be in floating. There you go. Go from scientific to floating. And maybe I'll give it 1 decimal place. One of the reasons why I'm giving it a decimal place is we're about to see that it's it'll show up in the graphing, but we also are going to probe some values we want to see in there. I have a range of 25, and I guess that'll work out with increments of 10. So let's leave that. And then lastly, for my display, in the settings, I like to change this to discrete. I think it makes a lot more sense when you're trying to analyze what this thing looks like. So here you go. So you can see here's the maximum as you would expect, and that's really close to 234 versus our 233. What you're going to find here, though, is on this von Mises takes sort of like the absolute value. So we can also go around and we could use in our results, we can go to probe, and we could pick various spots. So I'm going to try to pick over somewhere over here. Let's see, where did we go? It's not showing me the thing, so I'm going to pick like right over here somewhere. And you can see we get of 142.9. Compare that to 145. So that's really good. But you'll see it's positive because, like I mentioned, von Mises doesn't, it does take like the absolute value of it. There's no shear really going on here anywhere. So we're really just looking about all normal stresses. So the von Mises gets rid of shear stresses. But yeah, anyway. You could also do something along these lines. Here's a plot tool where you can list. And so this is really useful right here, is if you can find what happened. You know, I think it accidentally got rid of that one plane. It did. When I did the undo, it got rid of that plane. So let me see if I can fix this. It'll get mad at me. It'll almost certainly be mad at me for doing this, I think. But I'm going to try. I'm trying to include that fit plane again, curve split line I'm in, and that plane in this body. Yeah, it removed that one. I didn't mean to remove that one, but so now we're going to come back to this, and it's going to be angry right here. It's going to be angry at the force, so I have to edit that definition. And yeah, it was mad about that. Okay, so there's 300 and top plane. I think everything's fine now. Yeah, so you can just rerun it and run. So it did. I think it did did it do the mesh and run? Yeah, it did the mesh and run. Okay. So got the same value here. But now we can go to this right here, plot tools, and list selected. We can grab a hold of that curve and hit update. It gives us a bunch of numbers, but we can also plot. So you can kind of plot, you can kind of see, boom. And these are all the nodes that have landed right on this curve. Now, one of the reasons why to do that is so that you can get nodes that will land exactly onto the location that you want. And you can see that right here, we could hover over there, that we get the 233, and you hover over here, and we got the 145, oh, damn close. You can also, we could go back and do a little bit of refinement here. I'm sorry, go back to this. Go to the mesh again, create mesh, and it'll tell you that you're about to wipe out your solution. That's fine. I'm just going to crank it up to fine. And there you go. And then you can solve it, and it'll take a little bit longer, usually. You might not be able to tell. There you go. And it didn't really quite change that value. But let's go and take a look at this value list selected. Up here, update. And look how much more refined that is than the other one, right? But still right up in there. Still look at like a little slope thing going on there. But we still have the 234, and over here we have somewhere in the 240, 244. I mean 144, excuse me. Worked out pretty well. Let's get rid of that, and let's do this piece right there. I think that's where BB is. It's where that guy is going to be, and we anticipated update and plot that's going to be 103. How do we do? Not as well. We got 103 compared to this 116. And, oh, where did it go? And we got 84 compared to 72. But some of the thing is, well, you know, whereabouts do they actually mean for this to be right here? That's sort of the question. But it's we did have a good job right over in here on this one. If you coming back to this, let me get rid of that. One thing I had shown in class, so let's animate the thing. And we can slow this down. We can kind of see how these things are distributed right in there. Another thing that we could take a look at is we could change the, let me see, where am I? Section clipping. So that is, so you can see right here where we cut the thing in half, so you can see a little bit better through the side. Or maybe you want to change the plane. I think you change the plane, like go through that plane instead. So you can see through it, and you can kind of see what's taking place. We could also, right, this is all von Mises stress. Let's go ahead and change the stress to being, edit definition, to being in the normal stress in the x direction, right? So the x direction is upwards from this coordinates, you can see down here. And I will change the chart options. So now let's go to negative 250, right there. Not as nearly as much fun, right? Because the negative doesn't get into the plotting of the thing, but it has now you can see. You see it get a little of the blue, so it gets a little down into there. See, 0 is green. So if you went to the section clipping, once again, I gotta change which one it is. So go to that plane. That plane? No, it's not gonna do it. That plane. You can kind of see where it's coming through, right? It's neutral, or we could also do the plotting right here, plot tools. list selected. Select that, update, and then I'll plot. And you kind of see, there you go. Here's your, now you're going to be negative down here of a negative, what, there's 148, negative 148, and 144. And then right up in here you have your positive 235. So there you go. There's an example of your using SolidWorks simulation to try to do the curved, replicate the example, which is an excellent way to learn and understand FEA. And that is all for this one.